Benjamin Netanyahu revealed after the latest attack from Iran that he is working on a game-changing technology, a laser without a steering system, which will completely change the industry forever. Thus, Israel revealed multi-billion-dollar laser weapon that the country is spending billions of dollars. And with this weapons, Israel wants to have innovations that are far ahead of other military technologies. As Netanyahu reveals, after this product is tried, people will forget about its competitors, because this technology is so far ahead of the current competitors that it's not even close. That's why Netanyahu was very confident and declared that with this $1 billion laser technology, eventually Israel will become far ahead with its military tech development than its rivals. So let's explain how Israel reveals $1 billion laser weapon that changes industry forever. So Benjamin Netanyahu revealed that he is working on something special, something that is a once-in-a-generation technology. This updated version of Iron Beam will change the current state of military industry, earn a lot of income for its owners, and make their lives so much safer. And that's why Netanyahu revealed that he is very excited about this innovation. This Iron Beam will have an autonomous decision-making, real-time data processing, and enhanced learning capabilities through more powerful neural networks and quantum computing. In defense systems, AI will revolutionize how threats are detected and neutralized by improving the speed, accuracy, and precision of targeting systems. Netanyahu believes that in autonomous drones, AI-powered surveillance, and advanced missile defense systems like Israel's Iron Beam could leverage AI to predict and respond to threats faster than ever, optimizing the use of resources and enhancing overall defense efficiency. This new Iron Beam is designed to incorporate greater self-learning and adaptive capabilities, enabling AI systems to improve themselves without explicit reprogramming by humans. These systems will become better at handling unexpected situations, creating more robust models for real-time decision-making, and predicting outcomes with higher accuracy. AI will also leverage more advanced forms of natural language understanding, allowing for deeper interaction with both users and autonomous systems. Netanyahu said, "When you check it, you'll see it's really quite a wild experience to witness it. That's the future that we are entering, and it will get better and better." The country wants to produce a game changer that will reshape the military industry with cutting-edge design that will captivate both technology enthusiasts and those who are just entering the industry. Netanyahu praised the Iron Beam laser defense system as a groundbreaking innovation in Israel's defense capabilities. He described the technology as a strategic game changer that would revolutionize the nation's defense by providing an efficient, low-cost method of intercepting missiles and drones. Netanyahu emphasized how the system's ability to shoot down threats with a laser, rather than expensive missiles, would significantly reduce the economic burden of defense, allowing Israel to protect itself more sustainably in future conflicts. One of the standout features of the latest Iron Beam system is its silent and invisible interception capability. Unlike traditional missile defense systems that produce loud explosions and visible trails, the Iron Beam uses a high-powered laser to cook incoming threats with extreme precision. This process is silent and does not produce any visible light or explosion, making it a more discreet method of neutralizing missiles, drones, and other aerial threats. The biggest advantage of the latest Iron Beam system is its extremely low cost per interception. Traditional missile defense systems, like the Iron Dome, rely on expensive interceptors costing tens of thousands of dollars each, while the Iron Beam can neutralize threats for as little as $2 to $3.50 per interception. This cost efficiency allows Israel to conserve resources during prolonged conflicts, especially when facing high volumes of incoming rockets or drones, ensuring sustained defense operations without the financial burden that comes with missile-based systems. One of the coolest things about the latest Iron Beam that many might not know is its ability to integrate seamlessly with other defense systems to create a hybrid defense strategy. The Iron Beam doesn't replace these systems, but enhances them by handling smaller, more frequent threats like drones and mortars, while the Iron Dome takes on larger, more complex projectiles. And it's interesting to point out that this Iron Beam is not the first of its kind. There were a lot of countries that tried to invent something similar, and it all started many years ago. That's when in 1996, the Tactical High-Energy Laser, THEL, a joint US-Israel project started. It aimed to create a laser-based defense system to intercept and destroy short-range rockets, artillery, and mortar shells. The system was developed in response to growing missile threats, particularly from Hezbollah, which frequently launched Katyusha rockets at northern Israel. Thel used a deuterium fluoride chemical laser capable of producing a high-energy beam to neutralize airborne threats by heating and detonating them mid-flight. Early testing of Thel demonstrated its effectiveness, with successful interceptions of several test targets, including rockets and mortar shells. Despite its promising capabilities, Thel faced significant challenges, particularly with its high operational costs and logistical difficulties. The system was large, immobile, and required dangerous chemicals to function, which made it impractical for battlefield deployment. By the mid-2000s, the project was shelved as attention shifted to other missile defense solutions, such as the Iron Dome. However, Thel laid the groundwork for future developments in directed energy weapons, influencing modern laser systems like Israel's Iron Beam and other international laser defense projects. Though it never became fully operational, Thel represented a significant step forward in the exploration of laser-based military technology. Then in 2001, Skyguard, a laser-based missile defense system, was developed by Northrop Grumman as a follow-up to the Thel project. Designed to intercept short-range rockets, artillery, and mortar shells, Skyguard aimed to address some of the limitations of its predecessor, Thel, by reducing the system's size and improving its mobility. It was proposed as a defense solution for both military and civilian protection, with the ability to guard against incoming threats to cities, airports, and military bases. The chemical laser technology in Skyguard worked by superheating the target, causing it to disintegrate or explode mid-air. Despite its potential, Skyguard faced challenges similar to those encountered by Thel, including high operational costs, the use of hazardous chemicals, and the system's relatively large size, which hindered its deployability. The project failed to gain widespread adoption due to these limitations and competition from more cost-effective missile interception systems like the Iron Dome. Ultimately, while Skyguard did not reach operational deployment, its development provided valuable insights and technological advancements that influence future laser defense projects, including Israel's current work on the Iron Beam. Then in 2015, Lockheed Martin's Athena Advanced Test High-Energy Asset was revealed. This high-energy laser system was designed to disable threats like drones, vehicles, and incoming projectiles by using a concentrated beam of light to generate immense heat, neutralizing targets with precision. Athena operates on a principle known as spectral beam combining, which merges multiple laser beams into a single powerful output. During its 2015 testing, Athena demonstrated its effectiveness by disabling a truck from over a mile away using a 30-kilowatt laser to melt the vehicle's engine, showcasing the potential of laser-based systems for precise, non-explosive neutralization of threats. The compact design of Athena made it a key advancement in laser weapons technology. Unlike earlier laser systems, which were large and difficult to deploy, Athena was smaller and more adaptable, designed to be mounted on mobile platforms for military applications. And in 2024, Israel's Iron Beam is recognized as one of the most effective and advanced laser defense systems globally, capable of intercepting drones, rockets, and missiles at a significantly lower cost than traditional missile defense systems. With the current version proving highly successful in tests, Israel plans to release an upgraded version soon, and that's it for today.